Okay, so we just saw packs being used for high-speed precision control. But what about combining high-speed control with extreme reliability? And when I think about extreme reliability, I think about danger being involved. High-speed, moving parts, lots of danger. I don't know if there's anything up here on the stage that might resemble that kind of a situation, but Keith and Brian, why don't you tell us about our table saw here?
Table saws can certainly be dangerous, but this is no ordinary table saw, Tim. This system was designed and built by the SawStop company, and it features advanced control and processing technology that can stop the saw blade instantly to prevent serious injury. At the center of the SawStop system is a custom digital signal processing circuit, or DSP.
Now, traditionally, when designing custom hardware for a machine like this, prototyping the design can take a lot of time and increase your time to market. However, using Compact RIO and LabVIEW, you design your control system using LabVIEW tools, prototype your design using Compact RIO hardware, and finally deploy your design again using Compact RIO or other custom hardware like the DSP and the SawStop system.
So the Compact RIO R&D team decided to test out the performance and productivity of Compact RIO and LabVIEW by prototyping the custom SawStop control system ourselves. Brian, tell us how the electronics in this system stop the saw blade.
To detect when a person comes into contact with the blade, Compact RIO induces a sine wave electrical signal onto the blade and then monitors that signal at high speeds. Now, the human body has a large electrical capacitance, so when a person touches the blade, the amplitude of the sine wave will actually decrease. Wood, on the other hand, has a low electrical capacitance and barely affects the amplitude of the sine wave. So, Keith, why don't you go ahead and show how this works?
All right, can you get your hands off the controls, please? When I touch the saw blade with my finger, the amplitude of the sine wave decreases. But when I touch the saw blade with this piece of wood, there is no change in the amplitude of the sine wave. The FPGA in the Compact RIO programmable automation controller generates and monitors a sine wave at 5 microsecond rates. At the same time, the FPGA is performing digital signal processing and a reliable high-speed control algorithm that can fire the saw-stop brake in an instant. Now, the advanced I/O and processing requirements of this application are clearly a cut above the capabilities of a traditional PLC. Brian, how long did it take us to implement this system with Compact RIO?
Well, Keith, it actually took us less than 2 weeks to design, prototype, and deploy this control system using Compact RIO. We were able to incorporate high-speed timing, triggering, and digital signal processing directly on the Compact RIO FPGA. And we actually programmed all of that in about 2 days using LabVIEW.
Wow.
All right, that's enough talk. Let's put Compact RIO to the test. Now, Keith, since you manage the Compact RIO R&D team, I'm sure you'll be man enough to put your finger on the line to see if it works.
Of course I'm man enough, Tim, but you've taught us managers to delegate, so this finger is going to delegate to this hot dog to create the same effect as a finger coming in contact with the blade.
Hey, you know what, Keith? We also teach managers to be hands-on here at National Instruments. So, if you don't mind, I'm going to be hands-on. And
well, if you want to risk life, limb, and hot dog, be my guest, Tim.
Okay.
Wait.
Safety? Are you ready? Are we ready? Compact RIO, right?
Compact RIO.
Compact RIO. Here we go.
Wow.
Let me show you the hot dog here. You can see this in the camera.
Wow.
Barely a nick. Huh?
Now let's look at Compact RIO stopping the saw blade in slow motion. Our friends at Photon Focus lent us 2 CameraLink cameras, both of which are connected to the new NI PCI Express 1430 vision board. the top image that you see was captured at 1200 frames per second, while the bottom image was captured at a blistering 2700 frames per second. You can see the aluminum saw blade violently launching into or the aluminum brake pad violently launching into the saw blade to stop it, just in the nick of time. And if you want to see what one of these aluminum brake pads looks like after doing that, please visit us at the NI Pavilion down in the Expo Hall.
Wow. All right. So the moral is, so the obvious question is, would you trust your hot dog to a PLC?